Alright, so we're going to take a look at 2.6 notes today. These are families of functions. So here we have our family functions. A constant function is just a flat line. A linear function is what this one is called. This book says identity, but it's actually linear. That is any line, so that we have, if y is equal to x, that would be this line here. An absolute value function always has the shape of a V. So when we have those absolute value bars, our graph has the shape of a V. And then our quadratic function, when we have our x that's squared, our graph is in the shape of a U. So these are our family functions. These are the four main ones. And then if anything is happening to our equation, so let's say we had this x squared graph, but it was x squared plus 2. This plus 2 is a transformation that happens on our parent function that transforms our graph. So it'll move it some type of way. So we always start with our basic parent function, and a transformation is going to occur to it when we have something happening to our equation. So here we have some of our transformations. The first transformations we're going to look at are the vertical translation and horizontal translation. So translation is just a shift. Vertical is when we shift it up and down, up or down. And then horizontal translation is when we shift it left or right. Now, these are different by what's happening in our equation. So if we take our parent function f of x, so that's this orange graph in the middle here, that's our parent function f of x. When we add a number to it, so this plus k makes it shift up. So when you're adding a number to it, you're going to shift up. If you're subtracting a number to it, you shift down. Now, something similar happens when we have a horizontal translation. When we subtract or add from our input, so that's, we start with our f of x. When we are subtracting inside of the parentheses, so in our input, we shift to the right. So you would think that the right would be when you add, but it's actually the opposite when you are moving left and right. So when you subtract, you're moving right. And then when you add inside the parentheses, you're moving left. So if I had my parent function, let's just say it was f of x. Doesn't matter what the function is. Some function, f of x. If I add 3 to the outside, this 3 would mean I'm moving up 3 units. If I had my parent function, f of x, but I'm subtracting 3 on the inside. On the inside means I'm going left and right. When you subtract, just like it was here, subtracting means you go right. So this minus 3 means I move right 3 units. So for 2.6, there's not any math involved really. You're not adding and subtracting, you're not multiplying. There's no operations that are happening. We just have to look at our function and see what's happening to it and what type of transformation that is. So here, since we're adding 3 on the outside, it's going up 3 units. For the second example, the green one, we're subtracting 3 on the inside, so we're moving to the right 3 units. Let's say if I had one that was f of x plus 2. I'm adding 2 on the inside, so this would mean I'm going left 2 units. And then I could have another example here where I had f of x minus 4. This minus 4 on the outside means I'm going down 3 units. So these are two types of transformations, kind of one type, which is just a shift, but you could either shift it up or down. So up and down happens when it's on the outside, up or down, and then left or right happens on the inside. The next type of transformation we're going to look at is a reflection. So we have two different types of reflections. We can reflect it on the y-axis. So if you look here, this black graph is what we started with, this one. And it was mirrored on the y-axis, so it was just flipped over here to the green graph. We could also have a reflection on the x-axis, which flips it down below. So if you start with the black graph and flip it on the x-axis, you have the blue one. So two different types of reflections. So if you have a reflection on the y-axis, that would be when you have a negative on the inside. And then if you have a negative on the outside, this would be a reflection on the x-axis. A reflection on the x-axis. So the way that I think about it, kind of, a little helpful hint maybe, is that when it's on the outside, it's on the x-axis because you always want to keep your x's outside of your house. You don't want your exes to come inside the house. So if you had like an ex-boyfriend, you'd want to keep them out of your house. So if you have a negative on the outside, that's a reflection on the x-axis. And then if you had a negative on the inside, that's a reflection on the y-axis. One other transformation that we have is this vertical stretches and compressions. So if we're multiplying a number to our function and that number is greater than 1, we have a vertical stretch. So just think about it as if you're multiplying a number, you're getting taller, you're stretching. If you had a number that was in between 0 and 1, so that would be like a fraction or decimal. So anything in between 0 and 1, fraction or decimal, that's being multiplied to your function, you have a compression, so you're getting smaller. So these are 4 types of transformations on our functions. We have translations, which are shifts. So it could either be added or subtracted on the outside. Those are our vertical ones, so this would be up, this would be down. We have horizontal translations, which again are shifts, but these are shifts side to side. So if it subtracts on the inside, you're going right. If it adds on the inside, you're going left. And then we have reflections. So if it's outside, it's a reflection on the x-axis because you want to keep your x's outside your house. And if it's a negative being multiplied inside, that's the y-axis. So these are 4 types of transformations. So let's look at some examples. So here we're just dealing with the function f of x. That's our parent function. So this could apply to any parent function. So whether it was just like an x or an x squared or an absolute value, but we're just going to say f of x as like a general function. So in number 1, we're adding 6 on the outside. So going back to the slide before, if it helps you, have that slide open when you're doing your homework so you can see what your question looks like and you would know what transformation's happening. So when we're adding 6 to the outside, this would mean we go up 6 units. For number 2, we're multiplying a decimal on the outside. So this would be a compression because we're getting smaller. Because that decimal is in between 0 and 1, so we're getting smaller. For number 3, we're subtracting 4 on the inside. When you subtract a number on the inside, that means we go to the right. So we're going right 6 units. And then for 4, we have a negative being multiplied to the x on the inside. So this would be a reflection on the y-axis. So for your homework, your questions are going to look like these. Some of them will have more than one transformation happening to it. So you just have to write all the transformations that are happening to your function. So we'll look at the next page, and that has more than one happening to each. But your homework will look like this. The questions will look like this, and you just have to say that it's going up, or you're going to the left, going to the right. It's a compression, a stretch, or a reflection. Or it could be more than one. So looking at example 2, so it gives us the graph of f of x, which is this, and then we just have to describe the transformation that happens. So in number 5, plus 1 on the inside means that we are moving to the left 1 unit. And then minus 2 on the outside means that we're going down 2. So if we were to take this graph and shift it, because that's the only transformations that are happening here, we're shifting, we would go to the left 1 unit. So if I took this point, I'm moving it to the left 1 unit and then moving it down 2 units. So then my graph, it'd have the same shape, but just be out of that point there. So I just shift it down in the direction that it tells me to, and there's my graph. So same shape, just being shifted. For number 6, I have 2 transformations happening here. This 2 being multiplied to our function, 2 is greater than 1, so I have a stretch. And then 1 being added on the outside means I'm going up 1. So I would take this function here, stretch it so it's kind of being steeper like this, and then I just have to move it up 1. So instead of starting here at this point, I just start here, and it goes steeper like this. So that would be my new function. But again, for the homework, you don't have to graph. All you have to do is describe. So it would just be like this, how I described what each thing that's happening to my parent function does to my graph. All right, so just looking at the second slide from the notes again, just putting into context what everything we've done from the notes kind of means. If I had an absolute value function, so this was my function, this is my parent, it always has this shape. If I were to add 3 to this function, I would shift my graph up 3. So I start here, I move 1, 2, 3. My graph has the same shape, but I just shifted it up 3 units, and that's it. So this is just a shift of our graph. Looking at our quadratic function, let's say I took my x squared and subtracted 2. That would be off my graph. Let's say I subtracted 1. So I would just move it down 1, and my graph has the same shape, but it's just moving down 1. So it kind of gives us an easier way to graph. Instead of having to plot all these points, I just need to know what my parent function shape has, and then I can shift it according to what transformations are happening, what I'm adding or subtracting or multiplying to my parent function. So that is 2.6 notes. Make sure you turn in 2.6 notes at the end of class, and then you can start working on the homework. Again, for the homework, you just have to identify the transformations that are happening in each function. So if you have any questions on the homework, go back to example 1, and the questions are super similar to those from the notes.